Acharya Pingala was an ancient Indian mathematician who authored the Chandra Shastra, also called Pingala Sutras, the earliest known treatise on Sanskrit prosody. He was found around Maurya or post-Maurya era. His main interests were Indian mathematics and Sanskrit grammar. The Chandra Shastra is a work of 8 chapters in the late Sutra style, not fully comprehensible without a commentary. It has been dated to the last few centuries BCE. The 10th century mathematician Halayudha wrote a commentary on the Chandra Shastra and expanded it. His notable works were on Matrameru, binary numerical system, arithmetic triangle. Aryabhatta or Aryabhatta I was the first of the major mathematician astronomers from the classical age of Indian mathematics and Indian astronomy. His works include the Aryabhatiyam, which mentions that in 3600 Kaliyuga, 499 CE, he was 23 years old, and the Arya Siddhanta. He was from Gupta era. His notable ideas were explanation of lunar eclipse and solar eclipse, rotation of Earth on its axis, reflection of light by moon, sinusoidal functions, solution of single variable quadratic equation, value of pi correct to 4 decimal places, diameter of Earth, calculation of the length of sidereal year. He influenced Lalla, Bhaskara I, Brahmagupta, Varamahira. Brahmagupta was an Indian mathematician and astronomer. He is the author of 3 early works on mathematics and astronomy, the Brahmasphuta-siddhanta, a theoretical treatise, and the Khandakadhyaka, a more practical text. His works were on zero, modern number system, Brahmagupta's theorem, Brahmagupta's identity, Brahmagupta's problem, Brahmagupta Fibonacci identity, Brahmagupta's interpolation formula and Brahmagupta's formula. Brahmagupta was the first to give rules to compute with zero. The texts composed by Brahmagupta were in elliptic verse in Sanskrit, as was common practice in Indian mathematics. As no proofs are given, it is not known how Brahmagupta's results were derived. Bhaskara, commonly called Bhaskara I to avoid confusion with the 12th century mathematician Bhaskara II, was a 7th century mathematician, who was the first to write numbers in the Hindu decimal system with a circle for the zero, and who gave a unique and remarkable rational approximation of the sine function in his commentary on Aryabhatta's work. This commentary, Aryabhatiyabhyasa, written in 629 CE, is among the oldest known prose works in Sanskrit on mathematics and astronomy. He also wrote 2 astronomical works in the line of Aryabhatta's school, the Mahabhaskara and the Laghu Bhaskara. Bhaskara, also known as Bhaskaracharya, and as Bhaskara II to avoid confusion with Bhaskara I, was an Indian mathematician and astronomer. He was born in Bijapur, present Vijaypura, in Karnataka. Bhaskara and his works represent a significant contribution to mathematical and astronomical knowledge in the 12th century. He has been called the greatest mathematician of medieval India. His main work Siddhanta Shiromani, Sanskrit for crown of treatises, is divided into 4 parts called Leelavati, Bijaganita, Grahaganita and Goladhyay, which are also sometimes considered 4 independent works. These 4 sections deal with arithmetic, algebra, mathematics of the planets, and spheres respectively. He also wrote another treatise named Karana Kautuhala. Bhaskara's work on calculus predates Newton and Leibniz by over half a millennium. He is particularly known in the discovery of the principles of differential calculus and its application to astronomical problems and computations. While Newton and Leibniz have been credited with differential and integral calculus, there is strong evidence to suggest that Bhaskara was a pioneer in some of the principles of differential calculus. He was perhaps the first to conceive the differential coefficient and differential calculus. On the 20th of November 1981, the Indian Space Research Organisation, ISRO, launched the Bhaskara II satellite honoring the mathematician and astronomer. Madhava was an Indian mathematician and astronomer from the town believed to be present-day Alur, Irinjalakuda in Thrissur district, Kerala, India. He is considered the founder of the Kerala School of Astronomy and Mathematics. One of the greatest mathematician astronomers of the Middle Ages, Madhava made pioneering contributions to the study of infinite series, calculus, trigonometry, geometry, and algebra. He was the first to use infinite series approximations for a range of trigonometric functions, which has been called the decisive step onward from the finite procedures of ancient mathematics to treat their limit passage to infinity. He is known for discovery of power series expansions of trigonometric sine, cosine and arctangent functions, infinite series summation formulae for pi. His notable works are Golavada, Madhyamanena Prakara, Venvaroha, and Svatachandrapti. He is titled as Golewad, Master of Spherics. Dattatreya Ramchandra Kaprekar was an Indian recreational mathematician who described several classes of natural numbers including the Kaprekar, Harshad and self numbers and discovered the Kaprekar constant, named after him. Despite having no formal postgraduate training and working as a school teacher, he published extensively and became well known in recreational mathematics circles. Working largely alone, Kaprekar discovered a number of results in number theory and described various properties of numbers. In addition to the Kaprekar constant and the Kaprekar numbers which were named after him, he also described self numbers or Devlali numbers, the Harshad numbers and Demo numbers. He also constructed certain types of magic squares related to the Copernicus magic square. Initially his ideas were not taken seriously by Indian mathematicians, and his results were published largely in low-level mathematics journals or privately published, but international fame arrived when Martin Gardner wrote about Kaprekar in his March 1975 column of Mathematical Games for Scientific American articles. Today his name is well known and many other mathematicians have pursued the study of the properties he discovered. Shakuntala Devi was an Indian mental calculator and writer, popularly known as the human computer. Her talent earned her a place in the 1982 edition of the Guinness Book of World Records. However, the certificate for the record was given posthumously on the 30th of July 2020, despite Devi achieving her world record on the 18th of June 1980 at Imperial College, London. Devi was a precocious child and she demonstrated her arithmetic abilities at the University of Mysore without any formal education. In Dallas she even competed with a computer to give the cube root of 188,138,517 faster and she won. She went ahead to compete with UNIVAC, the world's fastest computer, to solve the 23rd root of a 201-digit number, and she won that too. A woman with outstanding talent and outrageous world records. Srinivasa Ramanujan was really a gem in the mathematical legacy. An undoubtedly greatest of mathematicians the world was ever witnessed. He wanted nothing and everything. He sought no wealth, but what he wanted, more than anything, was simply to be left alone to think, to dream, to create, to lose himself in a world of his mathematical fraternity. He was an esteemed personality with the highest academic honors, which was not conferred to any other Indians. In 1918 Ramanujan became the first Indian mathematician to be elected a Fellow of the British Royal Society, distinguished as a pure mathematician particularly for his investigation in elliptic functions and the theory of numbers. The will of God prevails. It is an experienced fact and often occurs that the lives of geniuses are short-lived in this material world. The culture between the world of Sarangapani Sannidhi Street in Kumbakonam in South India and the glittering world of Cambridge came to an end on April 26, 1920. The clouds covered the bright sun, the curtain closed permanently of the Sun of India. In his short lifetime he produced almost 4,000 proofs, identities, conjectures, and equations in pure mathematics. His theta function lies at the heart of string theory in physics. The mathematical fraternity has seen a Swayambhu, self-willed, self-directed, self-made, in its firmament, in the pinnacle of its glory. His works appear as manuscripts, a holy scriptures scribbled by Ramanujan for the mathematical world. After long years of losing him from his garden, still the flowers bloom with Ramanujan's flicks by the forefront of Janaki Ramanujan as well as geniuses of mathematical world Professor G. H. Hardy, Professor J. A. Litwood, Professor A. H. Neville, Professor Bruce C. Burnt, Professor Ken Ono, Professor S. Bhargava, my own professors Professor Chandrasekhar Adiga, Professor K. R. Vasuki, Professor R. Rangarajan, Professor Veena Matted, Professor D. D. Somashekara and the mathematical sprouts of the realm of mathematics. Demonstrably, Ramanujan has proved not only to India, but the whole world, what an unwavering mathematical spectre can do within a minimum interval of time, where even it is arduous for the others to clinch the same in their life expectancy. Professor G. H. Hardy said, "One gift has which no one can deny, profound and invincible originality."